Go.
Okay, so let's work on a kinetic energy problem because that's what you seem to be struggling with. Okay, so this one right here is our kinetic energy, right? The bird has a mass of 2 grams. It is flying at a velocity of 5 meters per second. Find the kinetic energy. Now, first question, what does kinetic energy mean? What type of energy is that?
The power that's moving?
It's moving, right? So it's energy of movement. That's why we have a velocity, right? Because that's moving, okay? Now, what are our units for kinetic energy? Or what's our units for all types of energy?
Energy.
Nope. Do you know units? Starts with a J.
Joule.
Joules, good. Our units for energy are joules. Okay, so now what I want you to do is I want you to copy this equation right here, and then you can just plug it in. Okay, so write it out. Okay, so what's the equation?
1 half. Mass. Times.
Yep,
Velocity.
yep.
Squared.
Okay, so in this case, what's given to us?
The mass.
Okay.
Which is 2 kilograms.
Okay.
But you have to take half of it, right?
Okay, so what's half of 2?
1.
Good. All right, so that's our
Times.
mass.
The velocity, which is 5 squared, which is 25.
Good. And 1 times 25 is?
So 5
And what are our units for energy?
joules.
Joules. Good. Okay. Perfect. All right, let's do one more. Why don't we do a specific heat problem because those ones are pretty tricky. Okay, so it says how much heat is gained when 114.3 grams of water at 14.8 degrees Celsius is raised to 18 degrees Celsius. This C stands for specific heat. So it says specific heat of water equals 4.18 joules per kilogram degree Celsius. What this C means is how much temperature does it, or how much energy does it take to raise the temperature of water. Okay, so for example, water has a high specific heat, but let's think paper. Do you think paper has a high specific heat? Is it easy to burn?
Yes.
Yeah, so it has a lower specific heat, right? It takes less temperature to change the temperature of paper than it does to change the temperature of water or gold or anything else like that. Okay, so what is our equation? Let's write out our equation and the problem. Which one is the heat equation?
Specific heat is
Or the specific heat equation is on here. Which one is it?
that. No.
It's the only one that doesn't have the
That.
yeah, with all the funny labels. Okay. All right, so write it over. All right, so it's Q equals. Right on the other side. Q equals
M.
M. Yeah.
Final.
Yeah.
Minus T initial.
Times C. Yep. Good. Okay, so what does this Q stand for?
Specific.
Yep, that's what the C stands for. The Q just stands for heat. It just stands for heat.
Heat.
Okay, so the Q is heat, the M is
The max.
the mass, good. The T is
The final.
final what?
The temperature.
Good.
Temperature final. Temperature initial.
And then the C is,
Specific heat.
right. Okay, so the reason this equation is kind of tricky is because the letters don't make any sense. Okay, so go ahead and plug in what you know. What are the units you know? What are the numbers you know?
The mass is 14.3.
Perfect.
The final temperature is 18.
Perfect.
The initial is 14.8.
Good.
And the specific heat is 4.18.
Okay. So you can go ahead and if you want to, you could just put that into your calculator. You just need to make sure you have the parentheses in there. Or you could subtract first and then put it into your calculator, whichever way you prefer.
Let's try it your way first.
That's fine.
18.0 minus 14.8.
Perfect. So what's your answer?
1,529.
And 20, we round it, so it would be 28 point.
28. Are you gonna round
No,
it
no,
to
no. I want you to round it to the tens, or the hundredths place, so 2 after the decimal.
Point 88.
Perfect. And your units on heat, they're the
Joules.
Good, because they're the same as energy, right? Okay, perfect. All right, so what are you going to do to ace your final on Wednesday?
Study my study guide and make sure I study